Alright, chemistry class, let's talk about naming ionic and covalent compounds. So, what do we need in a good name? Well, in the name, we should be able to go back and forth from the formula to the name. So from H2O to water, and water to H2O. Water is a common name. It doesn't really give us any information about what's actually in the molecule, but the other names we're going to learn today are going to tell us how to do that. So again, we're going to need to provide information on the types of atoms involved and how many of each are involved. So remember, first off, that ionic compounds are neutral. It's going to be something that's going to come up over and over again. So if we're going from a name to a formula in an ionic compound, it's pretty simple. You really just need to look up the charges and the symbols for the ions and then go from there. So let's go with an example, calcium hydroxide. Calcium, if you use your ion sheet, you can find that it has a charge of +2 and the symbol is Ca. Hydroxide is a polyatomic ion, and so it is OH and it has a charge of -1. So if we write those two out, we've got calcium with a +2 charge, hydroxide with a -1 charge. But remember that they're supposed to be balanced. A +2 and a -1 does not equal 0. It's not neutral, so it is not balanced. You can do one of two things to get it balanced. The first is the crisscross method. So if you take the charge and make it the subscript of the opposite one, so the charge on this calcium is +2, it becomes the subscript for the OH, and the charge of -1, which would just become the absolute value, which is 1, would become the subscript for calcium. So we get calcium with 1 calcium ion and 2 hydroxide ions. Remember, the parentheses show that there are 2 of that whole piece. So there's 2 O's and 2 H's. So, or we could use the least common multiple method. The least common multiple of 2 and 1 is 2. So what do you need to do to get them both to 2? Well, to get 2 to 2, you need to multiply by 1, so that's your subscript for the calcium. And to get from 1 to 2, you need to multiply by 2, so that's the subscript for hydroxide. Alright, let's talk about naming. So, it's really easy if we have ions that only have one possible charge. Those ions will be listed on your ion sheet just normally, and they will have no parentheses listed after the name. So some examples are magnesium with a +2 charge, sodium with a +1 charge, and oxide with a -2 charge. If all the ions only have one charge, all you need to do is write the names. So MgO, if we look up magnesium, our Mg, it's magnesium, +2, and the O is for oxide, and a -2. Remember, if there's only one charge, then the charge is going to have to balance out, and so that would tell us the number of atoms involved. So, for example, if we had sodium oxide, the name would still be sodium oxide, but we would know from the name and the charges that sodium has a +1 and oxide has a -2, that we would need 2 of the sodium and 1 oxide to make it balanced. So if we have ions that have more than one charge, this is where it gets a little tricky. If an ion's name on your ion sheet contains the parentheses and Roman numerals within the parentheses, then it can exist in more than one state. So we need to figure out what state it's in, what charge it has in that given molecule before we can give it a name. So CuO is going to have a different ion state for the copper than Cu2O3. Remember, again, ionic compounds are always neutral. Feels like I've said that before. So you can determine the charge by looking at the other side of the molecule. So if we know that the cation would be the first one in the positive ion, if it has parentheses after it, then we can use the anion to determine the charge. If it's the other way around, we do it the other way around. Duh. So let's go into that on the next slide. Okay, so in CuO, should be a space there, copper is the ion that can have more than one possible charge. If you look it up on your ion sheet, you'll see copper and then parentheses. So we need to figure out what charge it has. We know oxide, the O, has a -2 charge, so the copper, since there's only 2 ions involved, must have a +2 charge. Remember, they always have to be neutral, so the +2 and the -2 equals 0, and we're good. This Cu2O3 is a little bit trickier. Remember, again, oxide always has a -2 charge. So for the total negative charge, we've got 3 times a -2 because there's 3 oxygen atoms. So 3 times a -2 is -6, and we have 2 copper atoms, 2 copper ions actually, and since they have a charge of -6, or they have a charge of -6 for the oxygen, we have to have a charge of +6 for the copper. You can follow through the math here, or you can just kind of logically think it through that the charge on the copper has to be 3. So then when we get to the naming on the next sheet, if there is a ion with more than one charge, then put the Roman numerals after the name. So the first one, copper and oxygen, the copper had a charge of 2, so we put copper 2 oxide. The second one, we had copper with a charge of +3, so we put copper 3 oxide. So copper 2 and copper 3 oxide are very different and very distinct, and it's important that we give them names that reflect that so that we know what we're talking about. Kind of an extra little helpful hint, if you see something with Roman numerals, you don't have to look it up on the ion sheet. Like if you see copper 2, then you know it's going to have a charge of +2. If you see copper 3, it's going to have a charge of +3. Just a little heads up. So if we're using covalent molecules, the covalent rules are a lot different. Covalent molecules, we're going to use prefixes. So take a quick second, pause this, write down this list of covalent prefixes in your notes. You're going to need it. I'm assuming you've already done that, so we'll go ahead and move on. So if we're going from a name to a formula, just use the prefixes to figure out how many of each of the atoms are involved. So if we have carbon dioxide, we have 1 carbon and 2 oxygen. We have carbon monoxide, we have 1 carbon, 1 oxygen. Again, it's safe to assume that if there are no prefixes, then there is only one of those atoms. So we don't write monocarbon dioxide and monocarbon monoxide, because frankly, chemists are kind of lazy, and so they leave out any unnecessary information. So it's safe to assume if there's no prefix, it's only one. So if we're going from names to formulas, pretty easy. Look up the prefixes, figure it out. From formulas to names, we are going to first find the number of atoms in the first element, then write the appropriate prefix from before. So 1 would be mono, 2 di, you get the idea. If there is only one, the mono can be omitted. And then we write the name of the element. Then do the same thing for the second element. Write the appropriate prefix, and then write the name of the second element, changing the suffix to IDE. The prefix is almost always included, even if it is a mono for the second element, but there are a few occasions when it's not. For the most part, if you leave it in there, it's not going to be wrong, it's just extra information, so feel free to add extra information as necessary. The types of covalent molecules you're going to be naming are only going to have 2 atoms, so you only have to worry about going that far. So here's two examples of names to formulas and 2 examples of formulas to names for covalent. If you want to take a second, pause this, see if you're getting it, and then the next little bit will be your answers. So here are your answers. Hopefully you're getting this. If not, talk to me, and I will help explain it to you in a different or hopefully better way. That's all for now.